First, we need to acknowledge that the normal habitat for Salmonella is the gastrointestinal tract of animals. From there, it can become a problem to the animals for animal health, to cause disease in animals. So in pigs, we think about 2 serovars of Salmonella, which is a zoo. I call it the zoo of serovars. There's thousands. So we need to think about the lineage 1 and Salmonella monophasic, Salmonella typhimurian, and then you have Salmonella 𝗟𝗫𝗄𝘁𝘀, which is a problem in certain places, specifically.
Good afternoon, everyone, and welcome to another episode of the Swine podcast. I'm your host, 𝗟𝗶𝘀𝗁𝘀, and I'm excited because we're going to talk about Salmonella in pigs today with Dr. Carlos Gomes. Carlos, how are you?
I'm doing well, thank you.
Good. Well, why don't you introduce yourself to our audience for us?
Yeah, I'm from Brazil originally. Trained as a veterinarian in Brazil and practiced swine veterinarian medicine there for a couple of years before coming to the United States for grad studying. So I did my master's degree in Iowa. Awesome group there, a lot of good people. I was with 𝗵𝗺 𝗪𝗀 at the time. I was doing my master's. He was doing his PhD, I believe, so it was awesome. And then I switched from pigs to mouse to do a PhD in the mouse models because at the time I wanted to get more insights into the microbiome and immunology, mucosal immunology, and the reagents were more available in the mouse model. So I kind of switched to an gut inflammation model and then started learning more of the microbiome and immunology. And then did 2 postdocs. One postdoc was still in the gut microbiome, and then a second postdoc is when I switched back to the livestock, doing food safety with 𝗟𝗶𝘀𝗁𝘀 back in Nebraska, where I did my PhD. And that's how I got back into livestock and the pork industry.
That's awesome.
A worldwide leader in animal nutrition, 𝗍𝗫𝗄𝑗's portfolio of products includes methionine, the full range of vitamins, enzymes, organic selenium, probiotics, mycotoxin management strategies, and palatability products. With such a diverse offering, 𝗍𝗫𝗄 supports its customers with a broad range of expertise, tools, and services to help them maintain a competitive advantage. 𝗍𝗫𝗄, fueling predictable profits. To learn more, visit 𝗍𝗫𝗄 at www.𝗍𝗫𝗄.com.
Well, let's just start big picture here, Carlos. What are the main concerns with Salmonella for the pork industry? You know, oftentimes we might think about E. coli more for pork production, or we might think of Salmonella more, you know, in terms of the poultry industry, but Salmonella is a concern for the pork industry. And why is that, Carlos?
Yeah, Salmonella is, so when you think about, I like to think it this way. First, we need to acknowledge that the normal habitat for Salmonella is the gastrointestinal tract of animals. From there, it can become a problem to the animals for animal health, to cause disease in animals. So in pigs, we think about 2 serovars of Salmonella, which is a zoo. I call it the zoo of serovars. There's thousands. So we need to think about the lineage 1 and Salmonella monophasic, Salmonella typhimurian, and then you have Salmonella 𝗟𝗫𝗄𝘁𝘀𝘁, which is a problem in certain places, specifically. As far as I know, all 3 can be zoonotic, less so 𝗟𝗫𝗄𝘁 as far as we know. But typhimurian monophasic certainly can be zoonotic. So then it poses a problem for public health as well. But I think we always need to recognize that Salmonella is also an immediate problem for production because it can cause gastrointestinal disease, diarrhea, and with scours you need to then treat the animals, and comes all the cost of that. But then when it comes to public health, when the product gets out of the farm, so to speak, you have potential for contamination of products during slaughterhouse, the processing there, and all of that comes as a consequence of pigs being contaminated with Salmonella. Specifically, I would say more monophasic and typhimurian, which are more prominent for the pork industry. We think that the monophasic is kind of evolutionarily related to 𝗽𝗽𝗎, kind of originated from 𝗽𝗽𝗎, actually. They're very closely related, but they are the most important for the pork industry, I would say, as far as I know.
Sure. Yeah. Thanks for that introduction, Carlos. So let's dive in just a little bit deeper, right? One of your specialties is studying, genomics and specifically Salmonella genomics. So why does that study matter? Maybe start big picture for our audience that's maybe not as familiar, and then dive as deep as you want to, Carlos.
I think the first thing we need to recognize with genomics is that it improves surveillance. If surveillance is being done for regulatory agencies or even in the industry in-house, it improves surveillance because we can get more information. We can get information below, we say that we can get more information below the level of serovar, kind of a genotypic information as you'd get with pigs, cows being genotyped for a selection program by a genetic company. So if Salmonella, we can get that too. We can get genotypic information that allows us to identify strains with higher resolution and associate those strains to predictable outcomes, such as diarrhea in pigs or our spillover event causing an outbreak in humans. Genomics also can give us the prediction of AMR resistance because we can map the genes associated with resistance. That's another source of information. And genomics can also tells us, or the more we advance in it, it should be able to help us with mutations and functions that are associated with specific environments. Can we predict which are the functions based on genomics, population genomics, that allow Salmonella monophasic to jump from pigs to humans? That's a big question. And you need a lot of genomics data to tease apart the noise and get the signal. So that's how I would look big picture, how genomics can help.
Yeah, that's awesome. So just a quick follow-up question, Carlos. In your research and and others as well, how much variation is there within those genomic mutations of Salmonella? Swine producers are often familiar with 𝗿𝗫s, right? And 𝗿𝗫s mutates and shifts all the time, right? So in terms of using that as a benchmark, how is the genomics of Salmonella shifting with what we currently know?
Awesome question. When you think about Salmonella genomics, some of the things we need to keep in mind is this. Typically, any isolate of Salmonella will have more or less 4,000 genes. So a lot bigger than 𝗿𝗫s, right?
Yes. Yeah.
3,000 of those genes are conserved. They're present in every single isolate of Salmonella 𝗽𝗽𝗎𝗃. So then when you think about genetic diversity, like you think for 𝗿𝗫s, there are two sources of genetic diversity in Salmonella. One, mutation in those conserved genes. The other is the flexible genome, the accessory genome, which bacteria has in terms of transposons, plasmids, or even genes come with bacteriophages and whatnot. So typically about 2/3, 3,000 genes are conserved, 1,000 is flexible. So there is variation in that. Our way of measuring variability in Salmonella right now is essentially two ways. Mutations in the backbone of those 3,000 genes and presence and absence of the fluid content of the accessory genome. So then you get a matrix of ones and zeros for those genes, those 1,000.
Sure, yeah.
And you can do some machine learning with that and try to identify clusters. Once you identify clusters, the first question is, are those clusters associated with a branch of the phylogenetic tree? That's one question. Are those clusters allowing us to get a more refined picture of where the isolate's coming from? That's another question. And those are questions that FSIS, for instance, is using.
Sure.
Now, even with all that information, it's not easy to get a hand on which farm is this isolates coming from.
Gotcha.
Because the other side of genomics is epidemiology. We still need the epi. We still need the metadata. We still need routine sample collection. We still need all those observations. I would pose a challenge here, which is this, that Martin Wiedemann published a paper saying, should we be thinking of the control of salmonella as broad as kill all salmonella? Or should we be using genomics to predict the more risky genotypes that cause spillover? And then we can start narrowing our way of controlling it.
Yep.
I'm not going to say it's possible or not, but one thing I would say is this. Let's just think of Salmonella monophasic. You send a sample to the D lab, and it scours in pigs in the nursery. They identify Salmonella monophasic or typhimurium. Fine. Is it the same genotype that's going to be at the end with that pig that's going to go to the slaughterhouse, with that finishing barn? Are the genotypes that are circulating in the nursery the same ones that are going to be circulating in the finishing barn? Because if they're not, there's some kind of selection perhaps or drift that has happened.
Yep.
And perhaps in the nursery have 10 genotypes, but in the finishing product, just one. And then maybe that one is a potential risk for humans or not. But you see, now we start refining our understanding of what could be a problem or not. And of course, on top of that, we add the multi-drug resistance, the use of antibiotics, and all those things need to be part of the discussion, are essential. But I'll pose one question for the industry. You look at the poultry industry as a cousin. And when you look there, for instance, we look at surveillance done in the United States, Salmonella enteritidis, which is typically there in poultry. We see a very pristine population of very low predictable AMR resistance based on genes that we know. But then at the same time, we know that these birds can be colonized with Salmonella infantis, which is multi-drug resistant. So then if you say, it's always the antibiotic probing selection to maintain the Salmonella there, not really, because you look at Salmonella enteritidis and you see that's pristine, not very resistant at all. So then something else is leading to the survival of that in the gut of poultry. I would challenge the thinking into, it might be essential nutrients that the bug needs, physiology, just pure metabolism, or even the microbiome that has accommodated that 𝗟𝗃 to become a member of the community. So those are some of the questions that genomics can help us try to understand. It may not give a categorical answer, yes or no, but it can help us.
Yeah, no, thanks for that answer, Carlos. And Dr. Gomes, that leads me into my next question to loop into, and that's how can the microbiome help us make the pork food chain safer? We talked about, the microbiome sometimes being a host, right? Making a nice little room for salmonella to basically, thrive in and continue to expand. So, Carlos, how can we use the microbiome to make our products safer?
I think the microbiome it's a fantastic discovery in science because it's helping us to understand a lot of how the animals can use specific nutrients that they could not have the enzymes on their own, the products produced by the microbiome that benefit the host, the education of the immune system, the colonization resistance against pathogens such as Salmonella. So let's focus on that, colonization resistance. Because when you think about colonization resistance, you think of this. There's a community here that is not going to allow these invader species to get in. That property in ecology is called resistance. It's a community that resists the invasion. Then resilience is the ability to bounce back from a perturbation. So if we just think about resistance, then we can think of this as this way. We need to understand epidemiologically, because when we look at the data, we see that in growing finishing barn, the data that we have from systematic reviews, is that the prevalence of Salmonella can vary from 0 to 30, 50%. So immediately a guy like me who looks at the microbiome, I think, what is the microbiome composition of the ones that have Salmonella invader versus the ones that do not? That's the immediate question, right? And we need numbers, a lot of numbers, to ask this question in hundreds of animals on both sides in a case control study to say which are the bugs here that are not here and are here that could prevent colonization of Salmonella. That's one question. The second question is, also diarrhea is happening. What is the community that allows it to bounce back and kick Salmonella out? Right? And then we need to think of the site of infection, because typically it's the end of the ileum and the beginning of the cecum, the ileocecal area. So the fecal microbiome may not represent it really well. What we know right now is this. The strongest correlation we have, or anti-correlation with Salmonella, is Prevotella. Prevotella is a core member of the swine microbiome that starts growing in abundance right about after weaning, when the solid food kicks in really hard. The point is this. At this moment, we don't know the species of Prevotella, and we don't know the strain of Prevotella. So then I'm going to pose two questions for the industry. One is this. If we think of epidemiologically in terms of population immunity, when you think about vaccines, we think of this. We need to get mass vaccination to prevent disease at the population level or at the herd level, right? We say 80% coverage, 90% coverage, and we can knock down the disease. Right. How about if we think of a probiotic development in those concepts? Thinking that we need high prevalence of animals colonized with it and high loads of it. So if we just take the case of Prevotella that I told you, after weaning is when Prevotella starts spiking, growing in frequency in the population, right? The next question for us is this. Is a herd affected by Salmonella typhimurium monophasic with lower prevalence of Prevotella? What are the strains? But let's just think of the prevalence. If you were to develop a probiotic, then you'd think of the same concept. I want to get as many piglets or as many pigs colonized with Prevotella to knock down that at a population herd level. And then you need to think of the other side. What is the community structure that would allow me to put Prevotella there and for it to become a core member of it? So there is a timing component as well. And then the other challenge, which is a bigger challenge that I know nothing about, is this. Okay, Carlos, you proved to me by the science that Prevotella is going to be good. Fine. And if you can tell me the species, and if you can tell me the strains, and you can tell me which kind of fibers they want to eat, fine. How do I scale the production of Prevotella in the industry, in bioreactors, to produce these in quantities that we can put in the diet? So I know nothing about that, but I know that that's the pipeline of an epidemiological lab, and then can we scale this thing? Meaning, one trait to develop a probiotic is, can we scale? Because if we can't scale, then we have a problem. But let me pose you an optimistic view. Perhaps we cannot scale Prevotella, but we know its cousins that it likes to grow with in the community. And we would be able to grow those and facilitate, because of cross-feeding and whatnot, we'll be able to grow those, a more amenable bacterium that species that would allow then, okay, I can't grow this, but I can grow its cousin that it likes to play soccer with. So let's put that guy there and see if that increases the abundance and the frequency of Prevotella. So that's kind of how I see it at the moment.
No, that's awesome. Which kind of leads me into my last question here before we get into some funner type questions here, Carlos. Not that this isn't fun, but a little unscientific, Carlos, is basically, from your viewpoint and your background, like what currently is untapped at the moment in terms of what we understand?
I think the microbiome and the industry has done a great job of looking at the bugs that we can do some work with, Lactobacillus and others. I think the industry has the capability with AI to develop the chemistry for the prebiotics for these bugs. I think the prebiotic could be an easy solution. I think the untapped right now is this, is to look at the microbiome as a continuum to understand, okay, I can know that the Prevotella is good for the herd to decrease the shedding of Salmonella and perhaps disease of Salmonella, but perhaps we need to think as well in the community, in the lactation with the 𝗍𝗽𝗀𝗃𝗃 that set the stage for that community assembly for Prevotella to get in. So I think we need to be looking at specific bugs for specific clinical outcomes or food safety outcomes, and then we need to look at the context and say what's going on with the assembly of the microbiome, and what's the best time to put these things there ecologically speaking. Those are the kind of things I think that the industry is going to evolve into pretty soon here.
Yeah.
And AI comes to help.
Yeah.
Machine learning, AI, those are all tools that are going to help us.
Yeah, especially just, as you're talking about in your first answer, Carlos, just, how big the genome is of Salmonella, for instance, right? And that massive amount of data, having humans break that down is tedious and time consuming, right? So if we can, even just from a data analytics point of view, speed up and make that process more efficient, the breakthroughs that we can make, I'm excited about, right? It's something that keeps you optimistic for sure.
Yes, and the other thing is this, the more we start sequencing genomes of these probiotics, the more we can predict the enzymes that they have, and then predict the chemistry we need to feed these guys to keep growing.
Exactly. It's a domino effect. Yes. Yeah. Yep, for sure. Awesome.
It's time for our famous three. Eastman serves veterinarians and nutritionists in agrochemical and animal health industries by helping them select, evaluate, and implement innovative nutritional programs. Eastman works with your team to customize your gut health approach in feed and water. Eastman's approach addresses nutritional and bacterial challenges and finds new ingredient preservation and hygiene solutions. Explore ways to accelerate and innovate your programs. Contact the animal nutrition team at eastman.com.
Cool, Carlos. Well, hey, I have some final questions for you so our audience can get to know you just a little bit better. The first question is, what is the biggest hurdle that you've overcome in your career that you're the proudest of?
Coming from another country and living in the United States for a long time, like right now, I've been here for 15 years with my wife and 4 kids. It has ever been an adjusting, and in English was a hurdle in the beginning, and then just adjusting to live in another country is something that we're proud of. That being able to be here for almost 15 years now.
Yeah, no, that's outstanding. I can't imagine, Carlos, like that. That's something you should be extremely proud of, and your family should too. So we're here in the Midwest. We're looking at, as we're recording this, I think we're supposed to get to like 4 degrees over the next week Fahrenheit, right? So let's think about something warmer. What's your favorite part of spring, Carlos, that you enjoy by yourself or maybe with your family?
I can start fishing.
Oh, yes.
I don't do a lot of ice fishing, but so start fishing again is a good thing for us.
That's awesome. Favorite fish to catch?
Well, in the area that we are here, it's largemouth bass mostly, but I'd like to expand the repertoire.
Yeah, that's awesome. Well, hey, hope you have a great spring and summer of fishing here ahead of you. What's your favorite pork recipe that you like to prepare?
Well, no doubt, pulled pork. Just going to the I-State Fair and get some pulled pork sandwiches.
Yes, you can't beat it for sure. All right. And then, Carlos, my final question is, you do have a change in your life. What do you want to achieve in your next chapter?
Yes, I have been an assistant professor at the Ohio State University Center for Food Animal Health for 1 year now. And but I have decided to make a change, and I'm looking for a position in the private sector as a research and development position in animal health. So I'm kind of seeking a new chapter here in the industry, which is to me is kind of just a blessing to be able. I started in the industry, went out for more than 10 years academic and in the academia, and then now bouncing back to the industry would be a gift.
Yeah, no, that's awesome, and wish you the best in that pursuit, Carlos. And thanks for your time. I know I learned a lot, and sure that our listeners do too. Anything that you want to end on, Carlos, that we missed or anything?
No, I think this subject is important. and we need more conversations, industry, academia, and producers, and more education, more understanding, because there are concerns, very valuable concerns about data privacy and things, how we deal with Salmonella genomics. But I just want to be a voice that puts some ideas out there.
Well, I think you definitely accomplished that in this podcast, Carlos. So thank you for your expertise. And that concludes this episode of the Swine It podcast. We release episodes every Tuesday wherever you like to listen to your favorite podcasts. Hope you have a great rest of your day. And until the next time, take care.
Thank you.